So that was those 6. These guys down here, you're computing the following using the exponent laws. So when you're multiplying, you add the multiplying same bases, you add the exponents. When you're dividing, you subtract. So this guy here would be -3 plus 5 is 10 to the 2. This guy would be 10 to the -2. And in scientific notation, we do use the negative exponents. We don't leave them as fractions. This guy here, D, would be 10 to the -8 because you're -3 minus 5. The beauty of this stuff is the example I showed you here yesterday. This thing can be rewritten as 8.0 times 1.2 times 10 to the 5 times 10 to the 8. This is easy to deal with. It's going to be 10 to the 13. This is where things get a little bit more interesting, but the numbers here aren't actually bad. Instead of doing 8 times 1.2, there is a mental math trick that you can use to make your life easier here. What is it? Does anybody know? You will have calculators for all of these things, but you can make your life easier without them. Okay, 8.0 times 1.2 is going to be awfully similar to 8 times 12. How's our mental math? What's 8 times 12? I heard it. Louder. 96. So if 8 times 12 is 96, 8 times 1.2 is just going to be 9.6. I didn't say you had to do everything by hand, and you are going to be allowed to use a calculator for this entire course, but there are ways to make your life easier. This one here is similar. I have 2.3 times 10 to the -3 divided by 1 times 10 to the -5. Now, this is one of those questions that could show up on Facebook, and people freak out about BEDMAS. It should be written like this, so that you're actually dividing by this whole number here. What you're going to get is 2.3 times 10 to the +2 is going to be 10 to the -3 divided by 10 to the -5. So it's going to be -3 minus -5 means you become more positive. And then the last guy here would be -20 times 10 to the -8, which isn't in scientific notation, though we could put it in scientific notation. Questions, comments, concerns on any of those? If I gave these to you on a test or a quiz, you would be allowed to use a calculator, but you'd have to show me the work that you did to get here. I'd want to see your use of the exponent laws. So if you are struggling with some of these things, or if the exponent laws were a long time ago, some of you may not have had math since first semester last year. Let me know. If there are no comments, questions, concerns, I'm going to go back 2 pages because Kai wants an answer to these 2 questions. How many minutes are there in a year, and how long would it take you to count to 1 billion? So how many minutes are there in a year? 525,600. Give or take a bunch of minutes, because how long is a year, really? It's 365 days, or if you have a physics teacher who's a little neurotic, it's 365 and a quarter. That's why we have a leap year every 4 years. But even then, it's not perfect. Give or take a bunch of minutes. And then how long would it take you to count to 1 billion in hours and in years? In hours, it's going to be 277,777.7 repeating hours. And just to give that some perspective, that's 31.7 years. So if you counted one number every second without sleeping for 31.7 years, that's how long it would take you to count to 1 billion. It's kind of a ridiculous number. Questions, comments, concerns? If you've got them, let me know. Otherwise, let's keep going on. Okay, first things first, find me this page here. I want you off of all of your devices because I would love it if you could have this conversation without Googling anything. At your table with the people you are sitting with, hopefully there's more than one of you there. Yeah, everyone's got some table mates. I'm going to give you about 10 minutes. I'd like you to go through this. There's a bunch of different scales here. So we've got your standard meter. 10 to the 0 is equal to 1. 10 to the negative 2, I'll give you the values here out of scientific notation, just perhaps that will help. 10 to the negative 2, or the centimeter, is 0.01 meters. A millimeter is 0.001 meters. This guy's going to it's going to lose all meaning here really quickly. 5 zeros, and then this is going to be 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8. This will be 1,000. This will be 1,000,000. This will be 1,000,000,000. 3, 4, 5, 6, 7, 8, 9. I want to see how good you guys are picturing these kinds of values. What I want you to do, we'll go through the actual objects as a class. I've got an app that I'm going to show you guys. I would like you at your table to discuss the kinds of objects you think show up on these different kinds of scales. These are all lengths. So it's the meter, the centimeter, millimeter, micrometer, nanometer, kilometer, megameter, and gigameter. What kinds of objects, what kinds of distances are we talking about for these kinds of lengths? Okay. This is what I'd like, and we could start by giving you some context. This is a meter. There it is. That's a meter. Okay. At your tables, discuss what kind of objects show up on those scales. Once you think, once you agree, or put your estimated object or objects in there, 10 minutes we'll go through, and I've got an app I want to show you to give you some examples of some of these objects that show up on the scales. Like Mark to go. So what kind of objects are going to be on the scale of a meter ring? Oh, we're good. Oh, okay. Like as far as you're picturing, I mean, this is easy. The meter's sitting right in front of you. The centimeters here, the millimeters even on this thing too. The millimeters are in the tiniest lines. So what kind of objects are a millimeter big? But then beyond this scale, it's going to be as far as you can reasonably picture. What kind of objects, perhaps that you're familiar with, that you've read about, that you've seen on YouTube videos or whatever, are going to be on those kinds of scales. It was, oh, she emailed me a photo. Yes, yes. That's not very I hear that this is easier than oh, substantially. Yeah. I mean, it's still hard when you screw around and don't put the work in, but it's substantially easier than physics. My average on the exam. 2 years ago, I didn't go. I didn't have to scale my test 2 years ago. Last year, I scaled my test 10%. This year, if I wanted to have a passing average, I have to scale it 30%. Exactly. So frustrating. Yeah, I hear you. I don't know what the solution necessarily is. I mean, my first solution is we don't ask kids out of grade 9 math that don't. There's that. That might be an option. I don't think there's anything wrong with just doing math twice. You give a lot of kids realization that, like, oh, I can fail classes here. 2, you'd be a. Well, I've got a whole bunch of them that are repeating. Yeah. I think I have 17 of my 77 are taking it again. But that's okay. So, a child Anybody else have something? Someone said I saw a dog. A large dog, absolutely. What other kinds of objects did you say were on here? The scale of a meter. Nobody wants to give me more? Okay, cool. Let's go small. The centimeter. What kind of objects did you say were on the scale of a centimeter big? Brad. What kind of an eraser?
Like one of those staples ones. Like something like it's like maybe like 2/3 or half.
Like this guy?
Yeah, something like that.
So you're saying half of this is 1 centimeter?
2/3.
2/3. Okay. An eraser. We can see right now how good or not that estimate is because I have an eraser and I have a ruler. Or did you mean this? This is the width here. Were you looking at the inch? Yeah, those are. An inch would be about half of one of these things, but the centimeter is going to be the width of an eraser. You want me to measure the thickness of a pencil? It's about a centimeter. So you're talking like an eraser. Let's change this to make Brad righter than he was. An eraser width of pencil. Now we got to figure out a way to prove Kai wrong. What kind of other objects did you throw on the centimeter scale? A blueberry. As soon as you start dealing with living things, that gets a little bit more difficult because you can find blueberries that are really small. You can find blueberries that are really big. But yeah, I would say that's entirely reasonable. How about the millimeter? What kinds of objects did you say were on the millimeter scale? Lachlan. The what? The end of a needle. Like the part that they actually put inside you? It's a big needle. Is it a big needle? I don't know. Okay, anybody else? What kind of objects did you guys say back there, Henry? Pencil lead. Now I've got I can start measuring stuff. Okay, so on a ruler, it's been a long time since some of us have measured things. The millimeter is this smallest gap here. So yeah, pencil lead could be entirely reasonable. That's your 0.5 or 0.7 lead. For which? We'll get there. We'll get there. What else is on the millimeter scale? Brad, what did your table say? The width of rice, not the length of rice. The width of rice. Okay. Some of these are going to be hard to check. Jaden, what did you guys say for the micrometer? Let's go small, yeah. Grain of salt. Now we're getting real small. Yeah. Strand of hair, like the thickness of hair? Like the thickness of hair? Okay. Hair thickness. Cool. Let's go small. Nanometer. What kinds of objects? Yeah. Sorry, Jack? Paper thickness on the nanometer scale. Okay, what else? A speck of dust on the nanometer scale, okay? Anybody else? Yeah, Henry. Ah, classic. Everyone throws the water bear in somewhere. That's the tardigrade or whatever it's called, right? Also, I think it's called tardigrade, something like that. He always shows up. Someone always mentions it. I love it.
I'm pretty sure.
Okay, let's go the other way. Before we check these things, let's go the other way. What's on the scale of a kilometer? What kinds of distances were you guys picturing? Yeah. Okay. So the straight line distance? Like if you flew a drone straight, you figure that's about a kilometer, or if you walked? Okay, so Abby Senior to McDonald's at Cabela's. We can absolutely check that on Google Maps. We will in a second. What other kinds of things are on the scale of a kilometer? Can you be more specific? Because Emma picked a road that is definitely not on the scale of a kilometer. Emma picked a road that's on the scale of a megameter. Different road. What road are you suggesting is a kilometer long? Colden, was that you? Can you be specific with your road? Mackenzie, okay? Like start to finish? Mackenzie's a good choice because it actually begins and ends. Old Yell Road would be a terrible example because it doesn't. It just goes forever. Okay, we've got a couple roads. We can take a look at those. Megameter. Yeah, say it. Highway 1. So for those of you who aren't familiar with Highway 1 starts in Victoria and ends in Newfoundland. It's a straight, relatively straight shot across Canada. And we did already pre-look this one up. Highway 1 is 7 megameters. So it's a decent example. The width of our country is about 7,000 kilometers, which is 7 million meters. Okay, what other kinds of things end up on the megameter? Sorry? No, not the gigameter, still the megameter. Okay, so flights are good examples to pick for things like this. Roads are a lot more difficult because roads have twists and turns and they go back and forth, there's hairpin corners and all these kinds of things. Flights are good examples. Yeah. Very specific. Munich to Lyon. We'll look it up. And then Lachlan, you wanted to jump to the gigameter?
Saturn.
What about Saturn?
Saturn.
The size of Saturn, okay? Wait, circumference is, that's a hard one to picture. Okay. You're suggesting Saturn. Okay. You are not the first person to suggest Saturn. Or diameter. You're suggesting the Saturn circumference. Circumference. Okay. Anybody else want to give me their estimate for a gigameter? The sun's diameter. So, I mean, we're picking large objects. We're moving in the right direction, certainly. Okay, so I have an app. That's what the music's been playing in the background this whole time, is this, it's really kind of lame music for such a simple app. Here's the app. It's going to be a picture of my child first, not the app. Wait for it. Okay. Well, come on, computer. You can figure yourself out. Okay, here we go. Let's review some algebra, shall we? The first part of algebra we're going to review is substitution. Something I harp on a lot with my grade 9, something that you've done a lot of, something that is still a struggle from time to time, is substitution. So this is really just, it is what it sounds like. Given sets of formulas and then given values that relate to specific variables, what does it look like to actually plug these things in? And I know some of you are going to find this wildly trivial, and some of you, and it's going to be a struggle for others, and that's fine. We're just reviewing. So given this formula has no context. It's a formula that we're going to use a lot in our second unit. We want to determine the value of D if VF, VI, and A have these values. So we've got, here's your formula. We've got VF squared equals VI squared plus 2AD. At this point, there's no context for it, but there it is. What we want to do is we want to take these values and we want to plug them in here. We want to make sure we do that properly. The way I always teach my 9s is that whenever you're replacing a variable with a value, replace that variable with a set of brackets and then put your object, whatever it is, inside that set of brackets. So this is what my formula is going to end up looking like. Just immediately beneath it, I'm just going to rewrite the whole thing. And D is the thing that we're looking for. Every variable I swapped out for a set of brackets. And I'm going to take these values and I'm going to plug them in. So I've got negative 20 as my VF. That was this guy right here. VI was negative 10. So that's going to go right there. And A, we're told, was 3. If I don't give you a calculator for this, evaluate what you can first. Even if I do give you a calculator for this, no calculator is going to solve this thing straight up. So in order to solve this thing for D, we've got some basic algebra to do. Solve out first what you can. If you don't put these brackets here, especially when you start shoving things into your calculator is going to give you different values. Be really deliberate about how you lay down your math. For example, if I have my negative 20 here, if I put negative 20 inside a set of brackets and I square the thing, what should I get? I should get 400. A negative times a negative, because that's what I'm doing when I'm squaring something and multiplying it by itself. A negative times a negative is a positive. 2 times 2 is 4. So 20 times 20 should be 400. There it is. What happens all the time, though, is I see students in a physics class. It's not a math class anymore, so we assume the math is easy. It's a physics class. That's where things should be more difficult. And I see students do this all the time. No brackets. What's that? What's the calculator going to tell you that value is? Why is it negative? That, yes. Because if you're not super deliberate about how you lay things down, and this is why I harp on something as simple as brackets. Because if you don't use the brackets appropriately, your calculator is going to do exactly what it's programmed to do, and that's BEDMAS. Exponents happen before that negative sign gets multiplied on. So be really deliberate. And if you don't stop to think about the math, and usually when students pull out a calculator, they don't stop to think about the math. If you're not really deliberate about how you use your technology, it's going to screw you over. And that's not the reason you want to get screwed up in math, in physics. So evaluate what you can. Negative 20 squared, we've seen it, it's 400. Negative 10 squared is going to be negative times negative is a positive. Positive 100. 2 times 3 is 6, and I've still got that D multiplied in there. And now I want to solve this thing for D. How do I do it? What's my first step? Well, my next step. Move the 100. How am I going to do that? Why am I subtracting? But why am I subtracting to do that? But why am I choosing subtract? You're right. Just so you're aware. Like, I'm not trying to mess with you here. But why is it? There's a reason why it's subtraction. What's the reason? Sorry? That is, I was hoping you were going to say that. So Ray Reed is suggesting that we subtract the 100 over. She's right. That's going to be the thing we do. But I want you guys, again, understanding the algebra is really quite important because, again, it's going to screw you up. Why are we subtracting by 100? Ray Reed suggested that we are subtracting by 100 because we're adding here. Yep. Why does it cancel out the 100? Not because you're adding here, but because why? Of what? The reason we're subtracting is because this 100 is positive. It has nothing, it doesn't actually have anything to do with the fact that we're adding here. It has everything to do with the fact that this 100 is positive. Yes, Colin. Yeah, that's ultimately what we want to do here. We want to get this variable by itself. We're moving the 100 over. Any terms that don't include that variable, we want to get rid of. The reason that we're adding here, or that we're subtracting here, is because this guy is positive, not because we're adding here. And so there's a reason for all the steps that you choose to take. And so much, and you, again, I know it's going to frustrate some of you because it does every semester, but I'm going to get as much as I can. This course is all about undoing what you think you understand about everything that your life experience has taught you about how simple things function. And so I'm going to be really picky about the reasons for why these things are the way they are. We're subtracting here because, and you all knew it, we're subtracting here, but it's because that 100 is positive. So these guys are going to cancel, as several of you have said. We're going to get 300 equals 6D, and then the last step is to do what? Divide by 6. On the right-hand side, we're going to get D alone. On the left-hand side, 30 divided by 6 is, 300 divided by 6 is 50. We want to make sure we're all on the same page with some of this stuff. Let's do another one. Example 2. Given the same formula, VF squared equals VI squared plus 280, we're going to determine the value of VI if these variables are true. So we're changing what we're looking for. We're looking for this guy now instead. So I'm just going to copy this thing down again. I'm going to put brackets everywhere we have information. And I'm going to fill them in. VF was this set of brackets here. It's 120. A is 25. D is 300. What are we going to do first? Anybody? Emma, you look like you're about to put your hand up. Square the 120, sure. If you square 120, what do you get? It's an awful lot like 12 squared. 12 squared's 14,400 equals VI squared plus, and now we're going to multiply this thing together. 2 times 25 is 50. 50 times 300, that's just basically 5 times 3, which is going to be 15. And we're going to add on the 3 zeros. Okay, what's next? Algebra from forever ago, yeah, man. How? We're going to subtract away this 15,000. We're doing the opposite operation. It's being added. We are subtracting. Oh, pause. We have a problem. This question doesn't actually work the way it's written. I forgot to change the value. We're going to change the 120 to 125 because that will make the thing actually work. I'll give you the value for what this thing should be now. This thing should be not 14,400. It should be 15,625. I forgot to fix that. So now when we subtract these things, 15,625 minus 15,000 is going to give us 625 equals VI squared. To get VI, what do I have to do? Emma, we want to square root, the opposite of squaring. The square root of 625 is 25. Cool. I want you guys to crank out example 4 for me real quick. Formula is different. Find me the value for A. Try that guy. This is the expression that I've got here, and I want to go about solving this thing. So 190 is just going to be 190. I really didn't need the brackets there, but that's okay. 28 times 4 is 112. And then up to this point, lots of us were on the same page. Nothing weird happened. You had a half, you had an A, and then you said 4 squared was 16. And this is where things started to get a little bit interesting. Lots of you guys had different techniques for how you approached it from this stage. One of the really important things to remember in math is that when you've got a string of things being multiplied together, yeah, that letter is in the middle there, but you can multiply in whatever order you want. So at this stage here, to make your life easier, you can almost kind of ignore the fact that the A is being multiplied in between there and just multiply these two things together. The negative half and the 16. And so what you're going to get at that stage is you're going to get 190 is still on that left-hand side. That's going to equal, the 112 is still going to be there. The negative half times 16 is going to be negative 8, and that A still gets multiplied on there. And there's a few things that I noticed that I'm going to address right now that I want you to be aware of. When we have, that I saw, so Brad, I'm totally blanking on the girl who sits beside me, Kayla. When she gets back, she's right there. Okay, we'll wait for a second because Kayla, I want to address something that Brad told you to write on your page that was wrong. No, we were talking bad about Brad because he led you astray. Okay, so some things that I noticed that I want you to be aware of. Looking at this stage here, lots of you got to this point, and this is where things started to diverge. Once you've got 4 squared becoming 16, the squared is gone. The squared has been used to make the 4 squared 16. On a few of your guys, I saw the squared still there, and the kind of mistake that's going to show up is you're going to square the 16 again. 16 squared is going to be 196? Doesn't matter what it is, it's going to be wrong. Once you've squared the 4 to get to the 16, the squared needs to be not written again. We've multiplied the half and the 16 together. Now we're going to subtract the 112. The mistake I see here all the time is people want to add the 112 over. They want to add the 112 over because we're subtracting in between here. But the 112 is positive. So to get rid of the 112, you subtract the 112. And when you subtract 112 from 190, Brad, you should get what? 78. You should get 78. And this minus sign still needs to be there. So now we've got 78 equals negative 8a. I saw some of you guys make some cool little substitutions. But again, when you're moving algebra around in your head, you got to be really, really deliberate about minus signs. Don't screw up the minus signs. At this stage here, we've got a minus sign. Some of you moved this over, but then you'd have to subtract the 190 over. You'd still have a minus sign in here somewhere. Now we're going to divide by negative 8. We're going to divide by negative 8. That's going to cancel, and we're going to get A is equal to 78 divided by negative 8 is negative 9.75. Yes, I'm aware that there's only 3 minutes left in the block. Don't zip yet. I'm not going to... do I give you one? No. I'm not going to give you any homework at this stage. Make sure you're really... you got to be really deliberate about how we do the algebra. If you'd like some extra algebra practice, let me know. Maybe wait till after tomorrow. Because we're going to play with some of this stuff tomorrow. We're going to continue with the lesson. You have no homework for me today. Have a great day. We'll see you later. When the bell goes, you may also go. It is, in fact, bad C.